Okay, by my watch, I make it time. So thank you very much for coming along. I know it's the last talk of the day, so I suspect everyone is now quite tired, seen quite a lot of talks, quite a lot of technical content, and are probably just hanging around because there's beer later. But thank you very much for coming, whatever your reasons. My name's Steve. I'm a senior developer for a company called Magix. So we're based down in Brighton, and we do software as a service recruitment products primarily. So products to engage recruiters and employers with the right professional audiences. I'm also a Microsoft MVP, and I run a small meetup group down in Brighton called .NET Southeast, which we host out of the Magix offices. I also have a blog, so if you want to find out any more information about some of the stuff I'm going to cover, I have blogged quite extensively about IHttpClientFactory and some of the features there. So if there's anything that you think I go over too quickly, you can find full code samples of a lot of the things I will show you there. And if you ever have questions in the future, please do reach out to me on Twitter, @SteveJGordon. And one other thing to point out, I have put the link there to the slides. So a lot of people take pictures of slides through the talk, but you don't have to. They're all online already. So just make sure you've got a picture of this slide, and then you're good to go for the rest. So the topic of this talk is kind of HTTP, making HTTP requests in .NET Core. And the reason that I feel this is a really interesting time to start talking about this stuff is that more and more of us are building microservices and smaller services that are communicating with one another. And quite often, there are some real-time needs, so we're going to use HTTP to make those requests. And so because we're now doing this more often, this is quite a vital part of our application code to make sure that we're doing it in the most correct way that we can, to get the best performance that we can, and to make sure that we're not going to stumble into any roadblocks. So basically in this talk, we're going to take some code and we're going to refactor it through the rest of the hour to subtly improve it as we go. So with that, let's talk HTTP. So just to set the scene, just to make sure everyone's expectations are kind of correct as to what we're going to cover in this talk, we're going to talk about IHttpClientFactory, which is a new feature that came out in .NET Core 2.1. We're going to talk about why we need that to begin with. So what are some potential pitfalls that you may run into before using IHttpClientFactory, and therefore why has it been introduced in the first place? We'll talk about how to use it. We'll look at simple examples to begin with of just kind of converting existing code in the simplest way we can. And then we will slowly add more and more features and layers in from the IHttpFactory client set. We're going to talk a little bit about this concept of outgoing middleware. How many people in this room are ASP.NET Core developers already? OK, good number. So you'll be familiar with the concept of middleware to bring your requests into your application in ASP.NET Core. And it's kind of how we handle cross-cutting concerns and requirements in those applications. Just as we can have incoming middleware for requests that come into the application, we can have this same kind of concept with requests that we're making from our applications. And this is a good place to do kind of cross-cutting concerns. If you have logging requirements or you want to do any kind of metrics and monitoring of your requests, using this concept of essentially middleware is a great way to do that. We're also going to talk a little bit about a library called Poly and how this can be linked with IHttpClientFactory to help us make our requests more resilient and to make our code better enabled to handle transient type problems. How many people were in Brian's talk before this one on Poly? Okay, about half. So we will kind of skim over Poly, but if you want any more information about it, I recommend you check out the recording of Brian's talk as well, where he can go into much more detail on these things. We'll talk a little bit about patterns and some recommendations I have for working with HTTP client, and then just generally some other improvements in .NET Core 2.1 that are worth noting. I am generally speaking about .NET Core today. There are some differences between what's available in .NET Core and .NET Framework. I'm generally speaking about .NET Core. So we're going to start with this piece of code. Spoiler alert, there are some issues with this code. But we're going to start with this because this sort of represents what you may see in traditional applications today. So this is just a controller, and we've got an action method on here. And in there, what we're going to do is we're going to make a call to the GitHub API because we want to get some data that we're going to shape into our own object model, and then we're going to return it. Now, before I move on, how many people have kind of got code like this in their code bases today or have seen code like this and are sort of vaguely familiar with this? OK, cool. So we're going to look at some issues with this code. We're going to look at some potential pitfalls and hopefully start to factor those out. The first piece I want to start with is this using statement here. So we've got a using statement over the HTTP client because HTTP client implements iDisposable. That seems perfectly reasonable because we've kind of all had it drummed into us that if you're working with something that is iDisposable, you should dispose of it when you're done. And we are done with it as far as we're concerned at the end of this request. But there are some risks and issues with this. When we create a HTTP client, we get a HTTP message handler chain, and this is the handler chain that's ultimately going to be responsible for, at some point, establishing a connection to an endpoint, somewhere that we're making this request to. When we dispose of the HTTP client, we dispose of that underlying handler chain, and then we dispose or we release the connection that we were using. That might be okay if we were running this once, maybe just as a startup for our application. But here we've got it on an action method. And this could be called 10, 20 times a minute, a second, depending on the load on our own website. And so this piece of code could be also scattered across many other actions. And so what we're doing in this scenario is we're creating many HTTP clients, many HTTP handler chains underneath there, and many connection pools that are going to be opened and closed very rapidly. The risk of this is that we can run into a situation where we run out of sockets on the machine. Because the way the TCP spec is defined is that when we actively close the connection, it doesn't immediately release the port so that it's available again for the OS to allocate to other processes. It will go into what's called a time wait state. Typically on Windows, that's about 240 seconds. And during that time wait state, that port is basically just sitting there. It sits there because it's not going to be allocated to other processes that may need to make outgoing connections, just in case there's any latent packets that are still working their way across the network. Because of this, that port is tied up for 4 minutes, and we have a situation where if we do this frequently, we're just going to sit with many, many ports sitting in this time wait state unnecessarily. And this is kind of what that looks like. So I took that piece of code and just chucked it into a loop and ran it 20 times to my blog. So on the left-hand side here, you can see I've got 20 different ports that ended up getting used on my local machine, all talking to my website, all sat in this time wait state. And they're just basically wasted at this point. And the situation that we can run into is if we do this enough and we exhaust all of the sockets, then our application cannot make any outgoing connections at this point. And the server that we're running this on, it's affecting all other applications on that server as well. There are no spare ephemeral ports to use. There's around 16,000 ephemeral ports roughly on Windows, give or take. But if you've got enough of that code that's just kind of dropping these connections very often, you can exhaust that pretty quickly. You will see that as a socket exhausting exception in your application. So what's the solution to that? Well, the recommendation up till the release of .NET Core 2.1 and ASP.NET Core 2.1 was to try and avoid continually creating and disposing of HTTP client. That was the simplest solution because it means we create the HTTP client and then we keep it around for a period of time and then we use the same connections that we've already established. This has some benefits because there's a small performance hit from establishing connections and doing TLS handshakes that we don't have to kind of keep taking the hit on as well. And ultimately, that's going to improve our application, right? So what we can do to achieve that, there's various ways you might want to do it. You might want to make this kind of a static HTTP client on some of your classes, or you may want to make it a singleton. Typically what I would have done is just register this in DI. So this is my startup class. I've got a configure services method in here where I can set up my dependency injection container. And I would just register a HTTP client instance in there as a singleton. And this means that I can inject it where I need to, and I would get the same instance time and time again. So if I were to update my controller now to take advantage of this, first I would add a constructor here, accepting my HTTP client from the dependency injection container. And then I can update my code a little. I don't need to create my own client anymore. I'm going to use that sort of singleton instance that's going to be created once for the lifetime of the application. So I can get rid of my using statement. Now, one thing I was doing in the previous code was I was setting some default headers on the client so that all requests through that client, in this case just one request, would have these default headers applied. With the singleton HTTP client approach, there's a bit of a risk to this. It is thread safe, but there are some properties on it that aren't. The default headers and the base address are some examples of that. Changing these could have effect on other components that are using this shared HTTP client instance. That's an easy fix for now. I'll just move those to the request and set them on the request per request basis. And then finally, I can update my code to use that singleton HTTP client instance. But unfortunately, software often has a but, and there is a but to this. With this approach, we've created that single HTTP client, and we're sharing it for the life of the application. And this means that any connections we establish will try and live for the lifetime of the application as well. The issue with that is that when we first establish a connection to api.github.com, for example, we're going to do a DNS lookup to get an IP address of a server to speak to. And once we've got that, we can establish the connection. But that IP address may not exist there forever. Particularly in cloud environments, things come and go. And typically, DNS is now used as a way of switching around those services. The biggest problem would come from an example of maybe using a blue-green deployment. So if you're talking to a service that uses that approach, maybe like Azure Web Slots, you might have a production and staging slot live at the same time, and it's just DNS which is directing traffic to the correct production instance. But if we've established that connection to production and then someone does a deployment and the DNS is used to switch what is considered the production live copy, we may be now talking to the wrong instance. So having these connections open permanently is kind of better from the socket exhaustion point of view, but not great from the point of view that we're now not honoring DNS in any way. And that's kind of where HttpClientFactory comes to the rescue. It was designed with various things in mind, but one of the main things that it's going to offer us is that it's going to manage the lifetime of those HTTP message handler chains. And it's ultimately those that are hanging onto the connection. So it does that by basically holding onto a pool of these connections, and it will keep them alive by default for 2 minutes. And so all the while it's handing out HTTP client instances, it will use the same handler chain and the same connection as long as those haven't expired. At the time that 2 minute runs out, it kind of just puts it into an expired pool and means that it won't be issued to any new HTTP client instances. So this kind of gives us the best of both. We're holding on to connections for long enough that we're not going to continually create ports and open ports that are then going to sit in this time-wait state, but we're refreshing periodically to ensure that we do pick up changes that might occur by closing and reopening those connections. And that 2 minutes is configurable, so if you know that the downstream system might change more often, you could shorten that life, or you can make it longer if you want to. The other things it does is it provides a central location for configuring kind of logical HTTP client instances. So we can set up different configurations for HTTP clients that we may need in our application for dealing with different services and endpoints. And then we can use those at will. And we'll see examples of 2 ways of doing that. It also codifies the concept of that outgoing middleware idea that I talked about. So we could always achieve outgoing middleware or the concept of it using delegating handlers. These have been around with HTTP client forever. But to set those up and then to pass them into the HTTP client took a little bit of manual work. With HttpClientFactory, a lot of that can be moved away now, and we can just use some fluent configuration methods to start applying cross-cutting concerns using these handlers in our code. It also integrates with Poly, as I said earlier. So this gives us the possibility of very easily wrapping our calls in policies that will handle transient situations for us. So we can try and make our application resilient to failures downstream, to services that are coming and going, particularly in cloud environments where things are being deployed very often and there may be short switchovers between services. It makes sense to try and handle those situations and not just fail immediately if something's not around for the first time we try to talk to it. And it offers initially some basic diagnostics and logging, and it does this using the ASP.NET Core logging feature, and you can turn this on if you want to see all of the requests that are being made through anything managed by HttpClientFactory. You can even get timings and details about the headers that were being sent out on those requests if you need to. So let's start with converting that code that we had so that we can move over to HttpClientFactory. And what we're going to do here is we're going to do this in the simplest way possible. So this isn't taking advantage of necessarily all the features of HttpClientFactory to begin with, but this is to kind of demonstrate the least work that you could do to take an existing application where you were managing your own lifetime of HTTP client yourself and actually do that through HttpClientFactory. So in my startup class, I've got this add singleton HTTP client that we'd been using a minute ago. I'm going to get rid of this now, and instead I'm going to use the add HTTP client extension method on the iService collection. So this is just provided by the library, This will be available to you if you're using ASP.NET Core 2.1 or above. It's included in the ASP.NET Core app meta package. If you're using just .NET Core 2.1 and you want to bring this in, you can bring in the Microsoft.extensions.http package, and then you can start using this in kind of like generic host kind of situations as well. So this will register the services we need, and that will do for now. So we'll move over to the controller again, and the first change is to adjust the constructor. We're not going to inject a HTTP client now. We're going to inject the HttpClientFactory. So now this will give us a factory that can give us the HTTP client we want to use. Then we can make a change down here so that we're taking advantage of that, and we're just going to use the factory to create a client. So we'll call create client. Behind the scenes, the factory will create a brand new HTTP client every time, so we can guarantee it's a unique instance for us. But what it will do is reuse that existing handler chain if one already exists that hasn't yet expired. Otherwise, it will just create a new handler chain and pass it into us. So this means that we don't have to worry about the connection lifetime there. And now we can just use that local instance. So that's kind of the bare bones, and there's very minimal work there to go through an existing application and just start swapping out instances where maybe you were registering HTTP client in DI or doing some other mechanism to create it. And that will kind of give you initially, without very little work, the lifetime management feature, so that you're now getting that connection management. But where HttpClientFactory starts to get more powerful is if we start to take advantage of things like named clients and later typed clients. We'll start with names because they're a little bit simpler to understand. And named clients is one of the first ways that we can create this kind of logical configuration for a client. So instead of just calling add HTTP client here, I'm now going to call this additional overload that lets me specify a named client. Now this is one logical configuration. I could register many of these one after the other to create different configurations for different services I'm talking to. In this case, I've named this one GitHub because it deals with the GitHub API. And then I can pass in this action if I want to that will allow me to configure the client. So when the factory creates the new client, before it hands it back to us, it will run this delegate. And this allows us to set things like the base address and default headers in one place. Because we're getting a new instance every time we ask for one, we can be assured that we're not going to have to worry about sharing this across threads because we should just be using the client and then forgetting about it. The reason it's nice to set them here is I'm setting these once. So anything that uses this named client is now going to apply this base address and default headers. If these change, I have one place to change them, and that's kind of nice. To update our code, we're going to make a few changes now in this controller. So the URL I was previously using, I can shorten just to the path, because again, we're using that base address. So if that does change, hopefully if the path stays the same, we're okay. This doesn't have to adjust. And this request headers that I was now adding, and I would have to remember to do this in every place I was making a request, I can get rid of, because now that's going to be given to me on the client that I'm going to ask for from the factory. And then finally, when I'm using the factory, I can just pass in the name of the client I want, in this case the GitHub client, to get that particular configured client back. So that's a nice way to kind of get started with those logical configurations. And already it starts to kind of layer in a little bit of additional value. The next step, and this is kind of the preferred approach from Microsoft, and probably my recommendation as well, is to look at using typed clients. This gives us a kind of nice typed way to basically encapsulate the logic for dealing with a service into its own kind of class. And that's quite nice because then we can move all of the code required for dealing with that service to kind of a single place, and we can kind of be honoring single responsibility. And also this then can be registered into DI and accepted where we need it. So I'm going to first create a typed client. And a typed client is just a class. I've named mine GitHub client. It doesn't have to implement any particular interface. There's no requirements for it to do anything there. I've created my own interface for this because when I later inject it, I want to be injecting the interface so that I can easily mock this out if I want to in testing. The only thing that we have to do specifically on a typed client is accept HTTP client in its constructor. And this is different to what we were doing earlier, where we were getting a singleton client. This will be set up for us by the client factory. So this is going to be a new unique client instance with or without an existing handler chain and existing connections, depending if those have expired or not. And here I'm choosing to configure the client in my constructor. We can configure type clients in the exact same way as we did with the named client, where we pass that action into the setup. But I don't kind of like all of that code sitting in my configure services method. And this feels like a good place for it. In my opinion, this class is responsible for dealing with GitHub, so this is where I kind of keep my configuration for it as well. But it has the basic same effect that we're now going to have a client within this class, and this is going to be a transient class in DI, so we're always going to get a new one of these as well. And then I can start creating methods. This is a method that basically does what we were doing in the controller previously. I can give it a bit more of a descriptive name now. I can kind of describe that this is calling for the repositories from the ASP.NET organization. And now all of the code that was in my controller sits in here. And I feel, again, this is a better place for that kind of logic. Controllers, in my opinion, are not the place to be making HTTP requests and trying to parse the responses and deserialize them. This is kind of a nice place. We're dealing with GitHub in here, and we've kind of encapsulated that logic. And we have one place to change this if we need to in the future. So now that I've done that, we're going to register this into DI. So I'm going to get rid of the named client for now, and we'll just replace it with one of the options for typed client. So in this case, because I've chosen to have an interface, I've given it a service type for my DI registration, which is the iGithub client, and then the implementation type is our typed client that we want to return. And that will get us going. If you wanted to do all the configuration there, you could still use the configuration delegate in there to set up the client base address and default headers. So that's registered into DI. So I'm now going to update my controller yet again, and this time I'm going to accept my iGithub client. So this has already made the controller a little bit more descriptive. We know kind of what services we're accepting here. We know we're going to be dealing with GitHub somewhere within this controller, hopefully. And now I can update my action and reduce that quite considerably and move away all of that code that isn't really the concern of a controller and just call the typed client now. And so we've improved the controller, we've moved the code and the logic for dealing with GitHub into its own class, and that's all bound up and handled for us in DI with the lifetime management that we need from HttpClientFactory. So I'll move on briefly to outgoing middleware. So I described earlier that we kind of get this same concept as the incoming middleware. So from an abstract point of view, your application calls HttpClient, it makes a request at some point over to an endpoint, and we get our response message back. But there's some stuff happening under the HTTP client that's kind of hidden away from us, and it's that handler chain that I keep referring to. So I haven't described the full handler chain here. There's many handlers that might be used, and it depends on things like whether you're trying to use proxies in the request and things like that. But at the kind of bare bones, we have the HTTP client handler that typically sits at this end, and the HTTP client will call into that. And it's a bit like it's a chain of handlers, but it's a bit like a Russian doll model. So the HTTP client handler is the kind of outer Russian doll. And then it passes the request. Once it's looked at the request, it might do something with it if it needs to. But then it can pass it into the next Russian doll inside and continues down through the entire handler chain until you're at the center. That's the socket's HTTP handler. This is the one that's actually responsible for sending packets out on the wire. So this will then issue the request. And then the response comes back in, and it flows back into that socket's HTTP handler and then back through the layers of the Russian doll model. So you get kind of two chances to look at these requests and responses, and you can inspect them in handlers. They could potentially modify those requests. They might do nothing at all. But because we have this handler chain, we can take advantage of that by adding our own handlers into the mix, and then we can do whatever we want here. Any kind of cross-cutting concerns for dealing with requests, we can put into a handler. And that might be things like checking for some default headers. So a particular endpoint requires headers on every request. You could do some validation here, and you could short-circuit this flow and decide to actually just return an immediate response that's a failure, because you don't even need to send it over the network in that scenario. You might do some kind of inspection of bearer tokens and applying new bearer tokens and authorization if that's required. You might do some kind of metrics and monitoring around your requests. And basically, once you've added these in, you're just stacking additional Russian dolls around the kind of system handlers to do your own work. And so with this flow, we can start to think about applying those cross-cutting concerns and hopefully simplifying our applications where we need to do stuff on every request. The way we implement this is using the delegating handlers. As I mentioned earlier, these have existed for some time, as long as HTTP client. But with the delegating handlers, you'd have to create a handler chain and put the handlers in the right order, and then you'd have to hand them off to HTTP client to make use of them. And that was not too bad, but it could be better. And with HTTP client, it has been improved. So what I've got here is a handler. The only thing that I need to do is implement or derive from the delegating handler base class, the abstract class. And then I can start to apply the logic that I want to. So this is a really basic one. I'm going to inject a monitoring service into here. You can inject services and use them. And then I can override the sendAsync method, which takes a request message and a cancellation token. The key line in here is this call to await base.sendAsync. So this is the line that will call the next handler in the chain. And because we've called it there, we could have done some work here before we've passed it along. In this case, this particular one looks to maybe send the status codes that I'm getting from this external service out to some kind of monitoring service that I'm pretending I have here. And so with this simple delegating handler, I can apply this on all requests if I wire it up. So I'm going to come in here, and I'm going to add this to my typed client definition. So when we create a named or typed client, what we get back is a HTTP client builder. And this allows us to chain together some additional configuration and logic that we want to apply when we're using that named or typed client. So in this case, I can tweak my code slightly. And I'm now going to make this call to the HTTP client builder to add a HTTP message handler. And then I can just pass it through the type of the handler that I want to add. So without any real ceremony, I've added a handler. And I could have many handlers here. I could layer them and stack them. This will be the first handler that we get hit, and then it will call through to any other handlers that I decide to add onto this typed client. The other important thing that you have to do is you have to make sure you register your handler into DI as a transient service so that it can be picked up by HttpClientFactory and applied in the right place. But with that, we've added that logic to anything that goes through this typed client. So we're going to get all of those metrics recorded for us. We haven't got to record that at the point of making every request. So I'm going to now talk a little bit about Poly. As I say, I'm not going to sort of go into depth into anything. You could easily talk for an hour about this. I know Brian just has. So like I say, check out the recording if you want to see the details of this. But at its heart, Poly is a .NET resilience library, and it allows us to be tolerant to transient type failures in our code. It's not just for use with HTTP client and requests. You could use it in anywhere in your application that you want to apply these kind of policies. But HTTP requests is a really good candidate because they can have kind of transient issues, and it would be nice if our code could deal with those in a really simple way. The Poly team have worked with the Microsoft team to integrate this with HttpClientFactory. So there's a really nice pattern for using this without too much setup. And basically the idea of Poly is it gives you a policy, and the policy is configured to handle some criteria. So for HTTP requests, for example, we may handle non-successful status codes or HTTP request exceptions, for example. And once we've told the policy what it handles, we then apply a particular action, a particular policy that takes effect in that scenario. And there's lots of different types. The most simple and the most regularly used is retry. And retry basically just takes a piece of code that you want to run and executes it multiple times if any of those conditions occur. So if you get a failure response, it can retry the request for you. And you just wrap the piece of code that you want to run inside the policy, and it will execute. With HttpClientFactory, we can set these up and attach them to all requests really easily. We don't even have to worry about modifying the place we're making the request. So retry is common. There are others. Circuit breaker is another potentially quite useful one. And it allows us to monitor for multiple failures of a particular action. So we might want to put this across all requests to a particular service. And then we can say if this service fails like 20 times repeatedly, there might be a bigger issue. And if we just keep hitting that with retries and blindly hoping that it will come back alive, we're probably just making the problem worse. So circuit breaker lets us set that limit, and once the limit's reached, it just pops open the circuit, and essentially it means that it won't let any more requests through. At that point, it basically sits open for a period of time, whatever it's configured to wait for, and then it will go to a half-closed state. At the half-closed state, it will let a test message go through, and if it succeeds, then it can close the circuit and everything's working again. So it allows us to essentially back off from that downstream system that may be struggling. There are other things like we can apply additional timeouts to execution of code. Bulkhead isolation is quite an interesting one and slightly harder to explain, but the basic idea is to try and reduce the possibility of a cascading failure situation. So if you're talking to a struggling downstream system and it's either backing up requests or it's continually failing and we're continually retrying, they will add more load to your service. It's going to have to make more requests, it's going to have to handle more exceptions, and that can have a resource issue on your system that may actually bring your application code down as well. So bulkhead basically lets you put a limit on a concurrent activity. So you could say for talking to a particular set of services, you might put them into this bulkhead. That means that a certain number of requests can be handled at once. And if the limit's reached, and it also has a queue which could be reached, then it will just stop accepting things. So it lets you stop using all of your resources to talk to a particular downstream system, and hopefully stops a cascading failure effect. There's caching policies that you can apply. There's fallbacks, which you can take effect if all other attempts have failed. Maybe you just want to return some kind of default. And we can combine these together with the idea of a policy wrap. And typically, we would at least combine like retries and circuit breakers and maybe fallbacks to give us a policy that overall will handle all of the situations we might expect from making HTTP requests. So to describe briefly what the retry looks like, this is our application at the top. There's a downstream service. It's on fire. They're not having a great day. We make the request message, and we get back a 503, which is probably quite optimistic if there's a fire, but still, we've got a 503. And what are we going to do in this situation? We can fail, and we can just return a bad request to our caller. Maybe we have some of our own retry logic that we have to implement, and that's code that we have to write that makes a retry attempt of its own. With Poly, we just create the policy up front that says, okay, if I get 503s, I'm going to retry, and you can retry up to 2 times. So the first request occurs, comes back as a 503, Poly kicks in and goes, yeah, I can handle 503, I'm going to re-execute that request for you. Comes in, still failing. And between the first and second request, someone puts out the fire, pretty good job. Poly kicks in, we get a retry, and this time we get the 200. So in this situation, although we may have delayed slightly the response to our caller, we've been able to handle the fact that that service was temporarily unavailable. The fire is a bit of a joke example, but typically, if services are failing over in cloud environments, or if you're running services in containers, they may momentarily not be available, and load balancers may not send traffic to them. This kind of situation may recover that kind of situation. So how can we do this with Poly and HttpClientFactory? So with the HTTP Client Builder, we can apply additional extension method in here. Now this is not available by default with the ASP.NET Core app package. What you have to do is bring in the Microsoft extensions.http.poly package. So Microsoft don't include by default any third-party dependencies where they can avoid it. You have to explicitly add that package via NuGet just so that you can start using the Poly integration piece of this. And that gives us access to methods like asTransient HTTP error policy. And in this example, what it's going to do is it's going to pre-set us up a policy builder instance. And on that policy builder, we're going to get back a pre-configured policy that's going to handle potential transient type issues. So 500 request codes, a 408 timeout, or HTTP request exceptions. Any of those scenarios, it will consider itself active, and therefore it will implement the policy that you define. So once you've got the builder, you can then use it to set up the policy you want to apply in this scenario. I'm going to use a wait and a retry. So just doing a retry immediately is kind of pointless. In most situations, giving it a millisecond or two will probably not mean that the downstream system is recovered. So it's good to kind of give it a little bit of a wait time before you do it. In this scenario, I'm saying, well, do 3 retries, up to 3 retries if you need to. And in here, I can use this kind of code to apply an exponential backoff. So this runs at the time that it's doing the retry, and we have the retry count, so we can use it to calculate a longer backoff period. Because the more retries you do, the least likelihood that the downstream system is going to recover quickly. And so giving it that little bit of extra time might just get you over that problem. So that's added it in, and that's all we have to do. Any requests that now go through that typed client are going to apply that policy automatically. And that means that we kind of just get the benefit without having to adjust any of our request code at all. Now, we can also do things like dynamically apply policies. The reason we might want to do this will become evident in a moment. But what I'm going to do is define 2 policies just using the Poly APIs. And I'm not really going to go into these in detail, but the first is a no-op policy. So this just looks like a policy, acts like a policy, but does nothing. So it executes the code once, and that's it. The retry is just the same as what we did before, but this time I'm manually creating this using the Poly extensions. And so now I have 2 policies available to me. And then in this code, I can use the addPolicyHandler extension method with an overload that lets me inspect the request message. So the way Poly integrations work is it basically creates a delegating handler, because that's the place to do cross-cutting concerns. And then it wraps the call to the base.sendAsync in the policy. But before it wraps it, we have the possibility of looking at the request message and inspecting things on it. So in this case, I'm doing a conditional policy by saying if it's a get, then retry it. If it's any other action type, HTTP method type, then apply the no-op. Now, the reason we might want to do this is because if we're talking to a downstream system, retrying a get should be safe. It should have no side effects. It should be an idempotent operation. And so we can do that fairly safely. But if we're talking to a downstream system with a put, a post, a patch, a delete, those typically could have some side effects. And what we don't know is that our original request didn't get to the endpoint we're talking to. So in that scenario, we could send, say, an order to an order entry system. It might receive it, it might store it, and then the response that it sends to us may just not reach us for some reason, some kind of transient network issue. And so therefore, we'll time out. In that scenario, if I haven't got a conditional policy, it would just apply a retry there. What happens if I send that order twice? If we control the system, it might be okay, but if it's a third-party service, maybe they duplicate the order, maybe they just accept it and realize that it's a duplicate and ignore that. Who knows? So this kind of thing can allow us to do inspection before we apply the policies. You can inspect anything on that request message. You could apply this conditionally to different paths. Maybe you want to use headers as a way of turning this on and off. So you could maybe have a no retry header that you send through on certain requests, and it will automatically avoid putting that policy onto your request for you. The final piece I want to show with Poly is the Poly Registry. This was a feature that I kind of helped request because I was using the policy registry and I wanted to find out how we would kind of interface the two. And so the simplest example of this is I'm going to create two timeout policies. I did those just because they're really short. So I put two timeout policies of different lengths. And then I want to use a policy registry. And this is just a store for policies. It's basically a dictionary under the hood. But it allows us to create those policies once and then reuse them across the application. And that's how policies are sort of intended to be used. They're thread safe, and reusing them means we've allocated that policy once. Some policies like circuit breaker expect to be shared. So with a registry, this is one place that we can register them up front, and then whenever we need them, we can just access them from the registry. So I'm going to call this add policy registry method. What it's going to do is register the registry into DI, and then it gives us back a reference so that I can continue setting this up. So now I can just add my two policies in there, giving them a name. And now when I set up my typed client, what I could do is say add policy handler from registry and just pass the name. So if I've got lots of typed clients for lots of different endpoints, this is a shorter way for me to define those once and start reusing them. And the final thing on HttpClientFactory that I included this because a lot of people ask a question about this is what about situations where you were traditionally setting up a handler, a HTTP client handler, with things like certificates or proxy configurations and things like that. You can do it with HttpClientFactory. You just need to tell it how to configure that primary handler. So in here, we have the full responsibility for creating the top-level HTTP client handler that would be used in this scenario. This is still under lifetime management. So the typed client that we're using here will still keep that for 2 minutes and then use a different one. But it uses this actual piece of code to kind of set up the handler and attach it to the HTTP client it's going to give you. I won't go too deep into that code, but just be aware that that's there if you have those more advanced configuration needs. So I want to move on from HttpClientFactory and just try and group together some other HTTP tips from sort of various sources that I've gleaned from reading lots of information, talking to various people at the Microsoft Teams, and watching other talks and things. The first one is to take care when you handle response content. So what do I mean by that? So in our method here, I've got these 2 lines at the bottom which are dealing with reading the content and then basically passing it into JSON.NET so we can deserialize the JSON string. The problem with this piece of code is this first line. We're basically reading the entire content into a string and allocating a string for that content, and then we pass it into JSON.NET. Now the problem with that is we're going to have a lot of allocations of strings here, and if the response content's big, which it could be if it's a big array of JSON data, if that was big enough, it could push it into the large object heap even. And so we're going to have a lot of allocations that could have a performance impact in our code, because that's all going to be managed by the garbage collector. And if it goes into the large object heap, you have a whole other set of issues around the potential for compaction there. So basically, this string is redundant, because all we're doing is passing it into JSON.NET. But JSON.NET supports deserializing from streams natively, so we should probably use a stream for this. Now, I could write all of that code manually. It's not a huge amount of code, but the much simpler option is to use the read-as-string async method. This isn't part of HTTP Client by default, but there's a Microsoft package in the web API.client package that gives us access to these additional extension methods. And this one just takes the type that we expect to deserialize into, and under the hood, it will use the JSON.NET streaming features so that we can actually avoid that additional allocation. There is a small issue with this in terms of like debugging experience, because some people want to be able to debug here and inspect the string. You kind of just have to deal with that. You could include it temporarily and try and remember to take it out, or you could if debug it or whatever. But this is a much better option for avoiding a potential attack vector as well. So if the client, the service that we're talking to was kind of taken over, they could just return for fun a 10 gig string of data in that content, and we just try to read that into a string. So that's an attack vector we want to try and avoid, and at least parsing it over the stream, we'll realize it's not what we're looking for, and hopefully we'll allocate a little less. Next up is handling errors. So we talked about Poly in terms of handling transient HTTP, network errors, server errors. But the other kind of error is obviously that we may get the response back, but it might signify an error, 400 or 404. I'm not handling that here. I'm just trying to deserialize the content that may not even be there into this IEnumerable GitHub repo. So we should always handle that. Here I'm just going to use the response.ensureSuccess status code. So this will just run through the code, check if it's a 200 range status code, and if it is, continue. Otherwise, it throws an exception. So in this case, the caller of this method has to handle that exception and be ready for it. Another option, probably my preferred option, is to try and not throw exceptions there. So instead, I'm just going to check, is the success status code property on there? If it is, then I do my deserialization. Otherwise, I return some kind of default. It's up to you what's kind of correct for the context you're working in here and what you might want to do, but do make sure you're in some form checking for that before you just pass the code on. I have seen things blow up just purely because they're trying to read content that isn't there. The next tip is handling cancellation. So avoid doing work you don't need to do. So if someone starts an activity and then kind of gives up on you, you don't want to continue doing a bunch of work for them. And that can include things like making HTTP requests that could be expensive operations. So the way we're going to do this in our typed client is first I'm going to accept a cancellation token into my method. This is just a standard way with async await of dealing with cancellation scenarios. So I've got my cancellation token. So I can do a few things. Potentially what I could do is quickly fail. If they quickly cancel this before we've even started making the request, let's get out for an exception and move on. But we can also pass it through to any of the async methods like send async, read as async, so that they will cancel their activity as well if it's signaled. The problem we're going to have, though, is how we pass that in. We're calling this from a controller, something that quite a lot of people don't seem to be aware of because it's not necessarily pushed that heavily, is that controllers can accept a cancellation token, and the framework will give you this automatically. So when it activates the controller and it activates the method, it will just attach a cancellation token that's tied to the current request that it's dealing with. And that means that if someone closes the browser or gives up on a request they've made to you, you'll get signified that that's happened, and then we can pass that through. So now we can avoid doing additional work if people have stopped calling us. The next tip is caching. This is another thing that could be easily its own talk, its own hour. I'm going to kind of give you the general view of it and a couple of pointers, but there's a lot more to this that you'll have to consider given different situations you'll be running into. But let's say I want to use caching in this application. So the easy option for me here is just use the ASP.NET Core memory cache as a simple option. This would work in a kind of single instance application. If you were doing something that's kind of real and you've got multiple containers running this service, you probably want to use distributed caching, but memory cache was a little easier to show. So I've added that in. I've got that service available in this application. I can inject now the iMemory cache into the typed client to start taking advantage of it. And then I'm going to update my method slightly. There's a couple of kind of key changes here. So the first that might not look immediately familiar is the bottom part. If you haven't seen this, this is C# 7, probably 0, but I'm not sure. But it's local functions, it's local methods. And it's basically a way to put a method inside a method where it's contextually sensible to do so. So traditionally, I would have used maybe a private method on the class for this. But in this case, it's really tied to this first method anyway, and I don't want other people within the class calling it from other methods in this class. So this way, I've basically kind of hidden it inside the first method, and it looks like a normal method, and I can call it in the right way. That can be defined anywhere in this method, but I've just put it towards the bottom, which is my preference. And then I'm using the memory cache. I'm calling the get or create async method on there. I need to pass a cache key, something to identify this by. And then what it's going to do is, if the cache item is there, it just returns it, and that's the end of the day. We haven't made any HTTP requests. We've avoided work. We've avoided load on our system and the downstream system. If not, it will set up an entry with a 5 minutes timeout and then just run that local function to make the request that we were doing before. There's so many ways you could apply caching. Poly has its own caching policy. I've never found that one the most friendly to use. And there are some gotchas. You want to potentially apply that maybe on your typed client. And in that case, what you'd actually be caching is, for all HTTP request messages, you'd be caching their actual HTTP response message for that particular message. There are some read once, or certainly you have to rewind them streams on the content that you get back on the response message. So sticking that thing into the cache could have problems for the second person that actually gets it out of the cache. There's also work to do with that response. We have to check if it's a success code and deserialize it. There's not much point doing that time and time again, so I prefer to kind of cache a little bit higher up here at the point of making the request. But you could just as easily use any other technique here. You could apply a caching policy from Poly to do this slightly differently if you wanted to. So kind of coming towards the end, but I'm going to start just talking about a few bonus tips. So the first is this concept that I read on Dominic Byers' post on his blog, so at least privilege. He credits it back to @randompunter. There's probably like a chain of people that have mentioned it. But it's the idea of using extension methods. So as a library author, you want to write some kind of SDK that allows people to communicate with your API, and you want to kind of do that in a really nice way. How do you know how they're going to handle HTTP client? You don't necessarily want to handle HTTP client yourself because you haven't necessarily got a good system for doing that. Particularly if you're a .NET Standard library, you don't know if you're running on .NET Core, that HttpClientFactory might not be available. If it is, you don't want to force it on them. So one option that Dominic Byer was looking at for the kind of the identity server stuff was maybe just create extension methods for what you need to do. And this, I liked the idea, and I've used it in a couple of places. So I'm going to create some extensions. I've got an extension method. This is basically doing what we've been doing before in the actual typed client. I've made it a little bit more general now, so I can accept the organization name into this method. And then the rest of the code is basically the same as before. And now I'm just going to make the appropriate request using that particular org name. But imagine now this isn't a library. I'm going to bring that library into my application. So instead of writing this code myself, I'm just going to use this library that I've been given. So I would just call the getRepos async extension method on the HTTP client. And I've controlled the creation of the client. I've used typed client and HttpClientFactory, but the method could be provided to me but in a very generalized way by someone else. So that's just quite a nice thing that I saw when reading through some stuff that I thought it was worth sharing. The second bonus tip is around using correlation IDs. This is less about like good HTTP request practice and more about avoiding a world of pain with distributed systems. We've built a bunch of microservices at Magix, and they're all talking to one another. Some of it's async, and we're doing stuff over queues and events. But certain times we're making HTTP requests because we need data immediately. And if something fails downstream, it's quite useful to be able to tie that all together. And so using a correlation ID from the very first entry point into an activity stream in your context of your kind of application or distributed app, apply a unique ID to it somehow, and then make sure you pass that through. Using correlation IDs, I don't have code examples of this, but I've got a small library up on NuGet, which basically allows you to do this. So what it will do in an ASP.NET Core application, you can add this in. It will add some middleware that will inspect the headers. It will look for a particular correlation ID header. That's configurable, of course. And once it gets that header, it can basically give us a context that we can flow through the rest of that request. And then we can pass that onto any outgoing requests that we're making with the HTTP client. And the way I've tended to do that in the past is to use a delegating handler to do that. It's a cross-cutting concern on all requests. So just have the delegating handler have access to that context that's got the correlation ID and make sure it attaches the appropriate headers, because we can modify those requests in the outgoing process of those delegating handler chains. So that's just worth kind of keeping in mind. The library's there if you want to use it. The ASP.NET team have been working on various solutions for kind of tracing and things as well. So I think they have their own activity IDs and things you can look at using. But I wrote this kind of before that was all available. So the final kind of area that I want to look at is just some other, this other improvement that was available in .NET Core 2.1 that it's worth knowing is available and kind of in place. So before 2.1, the way the end of that handler chain would work is when you got to the end of the handler, it would use OS-level APIs for making HTTP requests. So basically, there was a split path where you had either a kind of Windows approach or a Linux Mac approach. And on the Windows side, if it was running on a Windows platform, it would use a handler that called down to the WinHttp APIs to actually issue the HTTP requests. It was using libcurl on Linux. And the main problem that the team had with this was that actually there was a big performance drift in the two. libcurl and the integration there was not anywhere near as close in terms of throughput. And a lot of us now, if we're building kind of microservices, we're deploying them into Docker, we're deploying them on Linux containers, and so this has a performance implication for our applications. So what the team decided to do is to kind of rethink things, and they've rewritten all of the logic and the actual code for making a HTTP request as managed C# code, and they've used the sockets API to actually kind of just create a raw socket onto the OS to actually send the data over the wire. So they've brought in all of the kind of HTTP piece of that into managed code. So this is good because now they have a kind of consistent code base. They have control over how that works. And it's something the team are continuing to work on in terms of performance. But when they did this, they got much closer parity between Windows and Linux in terms of making those requests. And that was a free gain just by upgrading to 2.1. If you were making lots of outgoing requests, you got that performance boost by default because it switched on in 2.1 by default. If you can't use it, and there are a few reasons why you won't, one is if you need to use HTTP2 on those outgoing requests because they hadn't built that piece yet, then you would have to switch it off, and you just do that with an environment variable. But unless you have a specific need to do so, don't turn it off because you're just slowing your app down for no reason. And the team have continued to work on this feature as well. So in the 2.2 release, I think they reported another 60% performance increase, so doubling the kind of improvement on requests on Linux, and I think it was 20% on Windows. So there's much sort of gain to be got there, and that's from some of the other performance improvement work with span and things like that the team are doing. And I'm sure there will be continued investment to getting this as quick as possible because it's a common story that people are using this feature set. So we're kind of coming towards the end, and I'm just going to summarize and just try and let the information sink in that final time before everyone runs for beers. If you're using .NET Core 2.1, specifically if you're on ASP.NET Core 2.1, then do use the HttpClientFactory feature. It's there for a reason. It makes life easier, and the key thing is that lifetime management. If you don't want to worry about type clients and named clients and figuring all that stuff out, then you don't have to from day one. Just convert your existing app, make sure it's registered as a service, and then switch over to using the HttpClientFactory to give you your client instances. But once you've got that going, it's well worth time looking at factoring stuff into typed clients, in my opinion. That's the kind of recommended story from the team. It's going to make your testing easier because you're generally in places where you're consuming those things. You're now just testing a typed client interface that you might have, and you can just test that typed client once if you need to. So just switch that on. If you're using .NET Core 2.1 and if you want to use it, you still can. You just have to bring in that Microsoft.extensions.http package. If you're using doing any kind of work that could fail, then I recommend bringing in Poly. It's great for other situations as well. You might want to use it for talking to database services or other internal services, but it really works well with HTTP situations and particularly well with HttpClientFactory in the mix. Really do be aware of that read as string async, get string async, unnecessary allocations. Expect and handle errors from the services you're talking to, 400s, 404s, that kind of thing. Make sure you're dealing with those appropriately. Do try and look at passing cancellation tokens through any asynchronous work, and particularly in this scenario to avoid maybe making requests that you don't need to, cancelling them when the activity has been cancelled in advance. Cache wisely. Think about what you're caching. Think about how long you're caching it for, and the caching technology is the right choice. You could still fill up the memory on your local machine if you just use a memory cache. So put the appropriate limits in place. I think Damien and David sort of called out just kind of unbounded caches as being a kind of risk for ASP.NET Core applications in their talk. Pass correlation IDs through your services. Easy way to do that with HTTP Client is just to do it on headers between requests and then just pick them up on the other end. But ultimately, just kind of go and enjoy doing some HTTP. Hopefully, these tips have been useful. Thank you very much for listening. Please do leave feedback on your way out. It really does help me understand if this has kind of hit the mark. If you're putting yellows and reds in and you're not too scared, come and talk to me and tell me why you put a yellow and a red in. That would be really useful because I can make this better for the next time I do it. If you want to sort of reach out, at Steve J. Gordon on Twitter, my blog, which has got, as I say, a lot of articles on HttpClientFactory. I've got another one coming on how to test in that scenario as well. And some resources for you to kind of take away. These are included in the slide deck, but if you want to have them now, do take a shot. So the slide deck itself is on that link. Another plug for the blog, go and check that out. The ASP.NET Monsters post is kind of one of the first blog posts that talked about the kind of socket exhaustion issue, that I saw at least. So if you want a bit more detail on that story, you can go check out their post. You can see it's kind of a couple of years old. This has kind of been around as long as kind of .NET Core has been around as a potential issue. The official documentation, I think is quite good, but I wrote it, so I'm biased. But check it out, see if that helps answer the questions, and then check out my blog for some deeper examples. Poly, you can go and check out their site. They've got a really great wiki, so if you're trying to integrate Poly and you're trying to work out how to build the various policies, the wiki's really, really good. And then that post by Dominic Bayer that I mentioned as well. So I'll leave those up. I've kind of got 5 minutes if people have any questions they want to yell out. Otherwise, I'll hang around and I'll be down kind of near somewhere with beer after this. Yeah, the HTTP response message in website is possible. Should we dispose it? Haha, I had this conversation today. So I wasn't entirely sure. So the question is, if the HTTP request message and the HTTP response message implement iDisposable. And the reason they do that is if you're using streams on the content. The answer I've been given by Ryan, I'm not sure if Ryan's in here, but Ryan Nowak from the Microsoft team did HttpClientFactory. I was trying to kind of get a definitive on this. It kind of depends, but if you create the stream that's reading off of there, then you're responsible for sort of kind of clearing that stuff up. So you could use put a using statement around your response or request there. I think if you're using the Microsoft kind of reader string async, you're kind of okay because they deal with the streams lower down. But if you're not sure, you could put it on. I did have some slides in here where I showed doing it, and now I've taken them out on the basis that I think it's probably not necessarily always required.
Anything coming in Core 3 that fixes?
So the question is anything else coming in .NET Core 3.0? I've kind of vaguely followed it. The key things that the team were looking at doing with HttpClientFactory is some additional work on trying to integrate with the Poly metrics and monitoring if they can. So as and when that's ready in the Poly library, it'd be nice if when we apply these policies, we can find out like how many times things have retried and get some way of getting that information back out. And so once that's ready from Poly, then hopefully the team will find a nice solution for integrating that into what we're doing as well. I haven't seen any other major changes. I suspect some more performance gains, hopefully, as a sort of ongoing effort that they're making there. Yeah?
Just a really quick look at the correlation ID on GitHub right now.
Yeah, I can potentially.
On the HttpClientFactory, you're not using IHttp context accessor. Is it because it's not really thread safe, so you don't use it?
I didn't. There's some recommendation about not applying it where you don't need to, so that it's not there by default. So you'd have to actually ask for that service to be registered into DI if you want to get it into places where it's not naturally available. So I kind of just avoided using it for that reason, that I didn't want to force someone to have that correlation context there.
You added a middleware to read the header to have the info, so you added something in the iOS anyway.
So I've used async local to create my own correlation context, but it's much more lightweight because it's only just kind of carrying a couple of things around. So yeah, I'm not entirely sure if it was the right choice at the time, but it felt like a good way of avoiding people having that additional dependency. Anyone else? Yes? So the question is there a plan to bring FTP client or something similar? And my answer is I have no idea, I'm afraid. Anyone else? Okay, thank you very much. I appreciate your time.